Welcome guys. In this video we will see how to draw the section of solids in the AutoCAD software. Okay, you take the first one. Okay, an hexagonal prism of base side 30 mm and axis length 60 mm is resting on HP on one of its bases with two of the vertical faces perpendicular to VP. It is cut by a plane inclined at 50° to HP and perpendicular to VP and passing through a point at a distance of 12 mm from the top face. Draw the front top sectional view and the true shape of the section view. Now we will see how to draw this projection in the AutoCAD software. Okay, it is given that this hexagonal prism is resting on on HP on one of its bases. Okay, so this prism has two bases. So they are given it is resting on one of its bases on HP. Okay, with two of the vertical faces perpendicular to VP. Okay, go to the software. First set the units. Set it in millimeters. Next set the limits. I'm taking the size of A3 sheet as the limits here. Okay, next after setting the limit, give the zoom command, zoom all. Okay. Now we put a reference line. Okay, for a length of 200 mm. This is I'm taking roughly 200 mm. Now name this reference line using the text command. So specify the start point. I'm taking the height of the text as 5. Angle of rotation should be 0. So now after giving the text height angle of rotation, this cursor is blinking. So now you can type the alphabets. Above the line it is VP. Below the line it is HP. So now first thing is we have to draw the true shape. Okay, it is given in the question that this hexagonal prism is resting on HP. Okay, on one of its bases. Then you will get the true shape on horizontal plane. That means when you see from the top. Okay, type polygon. Enter the number of sides as 6. Okay, select the edge method. And you have to place the hexagon like this. Okay. So the side length is given as 30 mm. Okay, you have to place the hexagon like this because in the question the condition given is two of its vertical faces should be perpendicular to vertical plane. That means VP. So you have to draw. I'm taking this two parallel faces, two vertical faces. So now it is in this position. Now this face and this face are perpendicular to vertical plane. So you have to place the hexagon like this. And then you have to name all the corners using the text command. So it is a prism. So it is a prism. It will have two faces, one at the top, two similar faces, one at the top, another on the bottom. So for top face corners, I'm giving A dash, B dash, C dash up to F dash. Whereas for bottom face corners, I'm starting from P dash and going up to U dash. Okay. So this is P dash, B dash, Q dash. This one is C dash, PQR dash, D dash, S dash. This one is E dash, T dash. This one is F dash and U dash. So after naming the corners, now to get the front view, what we have to do, we have to extend a line, vertical line from all the corners up to this reference line. Okay. Next, from the reference line, we have to mark the axis length. Okay, the axis length is given as think 75 mm. I think we'll go and check it. Okay, the axis length is 60 mm. Okay. So now from the center line, you mark a line for 60 mm. Similarly, from all the corners. Okay, still. After marking 60 mm, connect all the edges. Now we will give the names. Okay, for bottom face, it is PQRS. Okay, text. So this is P. So within the bracket, I have to give U because U will come at the back side of this corner P. Here Q and T lies on the same line, corner Q and T. Q at the front, T at the back. Okay. So Q within the bracket T, and the last one R within the bracket S. Similarly, now we'll go and mark the top face. A within the bracket F. Here it is B within the bracket E. The last one is C within the bracket D. So now I got this top and front view for this hexagonal prism when it rests on HP. Now we have to mark this cutting plane. Okay, the cutting plane, they are given that it is passing. First you have to locate this position of this cutting plane, and then you have to mark this inclination. Okay, so it is given that it is located at a distance of 12 mm from the top face, and then it is inclined at 50 degree. Okay, first we'll mark the 12 mm from the top face. Okay, take a line, start from here. So from here it is 12 mm, so move to the right, and this horizontal distance you can take it roughly, and then again take a line from this point, switch off this ortho mode. Okay, now you have to, this length is, you can again take it roughly, so move to the angle box and specify the angle. The angle is 50 degree. Okay, so angle is 50, specify 50. Now you extend this line on the other side using the extend command, EXTEND, type extend and select the line. You extend up to this reference line. Okay, now if you measure this angle, this is 50 degree. Okay, now we will specify this position of this cutting plane. Okay, it is located at 12 mm, and we will mention the axis length also. Okay, now if you see, if you take this cutting plane is intersecting this rectangular faces, this edges at 3 points. You place a point at all the intersections using the point command, type point and specify point here. So it is not visible, go and change the point style. Okay. So now you can see the point style is changed. Similarly, you place a point at this intersection and here, and we'll give name to this points. Okay, using the text command. One is 2 and this one is 3. So now this cutting, after cutting this prism along this cutting plane, this top position get removed. Okay, so we'll have only this bottom position. So again you draw a line above this line on this bottom position so that you can highlight the remaining portion. So after getting the line, you select all the lines at the bottom portion and you increase the thickness. Switch on this line weight option. Okay. So this is the cut portion. So now we have to mark this cut portion on the top view also. So for that you have to project line from this intersection point. Okay. So already this line is projected. Okay, for this intersection point, the line is coming over on this line itself. Similarly, for 2 also it is coming on the line itself. So for 3, you have to mark the line, come up to this reference line from here. Press F8. Redraw it. Okay, start from here. Okay, you have to go up to, so you come up to this edge, and from here you go to this edge BC. Okay. Okay, now we will highlight the cut portion at the top view. We start from here. Okay, now we will select. Okay, this the portion encompassed by this these lines. Okay, this represents the cut section at the top. Okay, so I'm going to increase the thickness. Okay, I will put a hatch on this cut section area. So here you have this hatch command. Select this hatch command. Okay, and select the type, which type you want. Okay, this one I'm selecting, and you click on this space. Okay, so if you want to increase the thickness, okay, reduce this, sorry, increase the density, you can reduce this value. So that you can increase the thickness, so you can increase the density. Okay. So now what we have to do, now we have to get the true shape of this cut section at an arbitrary plane. Okay, so I'm going to create an arbitrary plane parallel to this cutting plane. So we will draw a line up to this F1 line. We will draw one more line, start from here and up to E. Using the offset, go double up SCD offset, enter. So on offset distance, type randomly, I'm taking roughly 30. So I'm selecting this cutting plane. So this 30 mm is enough. Okay. So you should place this arbitrary plane in such a way that it should not intersect with the prism. Okay, that is its minimum. So if you want, you can take 40 also. Okay. So I would suggest 35. Okay. So it is now the line is very close to this prism. So you better take 35 or 40. Now we have to put a line from this intersection point connecting this arbitrary plane, this line at 90 degree. Okay. So start from here. So you can use this dynamic input. Okay, 30. Angle should be, so the angle it is calculating from here. Okay, so this is 50 and this is 90. Okay, 50 plus 90, it is 140. Now click copy, select this line, enter, and select this point as base point and put a line at 2, so that's that 0.3. Okay. Now what we have to do, now we have to translate this distance, okay, this from reference line to this each corner. Okay, so this from reference line to each corner we have to translate this distance to here, only in the uh, sectioned portion. Okay, only in the cut section portion. So first I will mark this corner A. Okay, corner A. So first we have to measure the length, how far the A is located from this reference line. Okay, so for this what you do, you take a line. Okay, you take a line and you draw a line up to A. Okay, you increase the thickness as well as change the color so that it is easy to track that line. So now select this line, select copy, and select this point as base point. Okay, select this point as base, copy, select this object, enter, and select this point as base point and shift it here. And now you rotate this by this is we have to rotate it by weight. I will tell you the value. Okay. So we will calculate this angle first. I think this angle should be 40. Yes, this is 40. Then we have to rotate it by 90 plus 40, 130 degree about this point. Okay, in clockwise direction. Again, take, select, rotate, select this line, and select this as base point. And we have to rotate in clockwise direction, but the system default rotation is anti-clockwise, so you give minus 130. Okay, so you have to position like this. Next, okay, this end point is point A. Okay, this is point A, so put a point. This is point A. Okay. So I will mark this as a point A. Okay. Now we will mark the point F. Okay, mark the point F. So again take a line. Okay, again take a line, go up to F. Okay, select this line. Increase the thickness and change the color. Okay, this time we'll take red color because both the lines are coming on the same line itself. So okay, so you take this as red. Okay, now go to click copy, select this line, enter, select this as base point. Again go to this point. Now click rotate, select this line, enter, rotate about this point. Okay, now you have to give minus 1. Okay, put a point, this point F. Okay, next select this line. Okay, how far this E is located from this reference line. You change the increase the thickness and you mark it in red color. Okay, now select copy, select this line, select this as base point, put it here. About this point you rotate this red line by again 130. Now we will mark this point B here. We'll translate the distance how far this B is located from this reference line. That distance you have to translate here. So again take a line. So you draw a line starting from here up to B, okay, and select the line, okay, increase the thickness, and now give yellow color to this. So first mark the point B and then you can mark the point E. Okay, we'll put a point here to identify this point. Okay, okay, this is, I will mark the alphabet. Okay, this is point E. Okay, then and there you mark the alphabet so that it will not be confusing. Okay, now select copy, select this entire line. Okay, enter and move up, take this as base point, keep it here. Now you rotate it by -130. So I will rotate it properly, so I will do it again. So select this object, take this as base point, fix it here. Now select this line, rotate about this base point by -130. Now it is coming on the line itself. Okay, now put a point. Okay, this is our point B. Okay. Okay, now this third intersection, this third point on this cutting plane is intersecting this edge, this ED edge in between. Okay, so we'll mark, we'll give a name here to this intersection. So I'll put a point here, here and here, and I will give a name to both these points. I will take it as G and H. So again, use the text command, enter. So I will take this point as G dash and this point as H dash. Now what we have to do, first we'll mark the point G. Okay. Select this line, increase the thickness, and change the color to red. After increasing the thickness, now you translate this line to this point. Okay. Copy, select this line, there, select this as base point, shift it here, and now select rotate. Right about this point -130. Okay. Put a point here. This is point G. Okay. Now we will locate the point H. Again, take a line. Start from here, go up to H. Select the line. Okay. Increase the thickness and change the color to yellow. So now select this line, copy, select this object, enter, this as base point, shift it here. Okay. Now rotate it by -130. Now this is point H. Okay. Now we got this all the corners, cut section of all the corners. Now we will connect. Okay, take a line. So we'll see A to F, F to E, E to G, and G to H, H to B. Okay. So A to F is already connected, so I'm going to connect from A to F to E, E to G. Okay, G to H is already connected. I'm starting from H, H to B, and B to A. Okay, this is the true shape of the cut section. So we will give separate color for this. Okay, and I can check it as. Now I can use the hatch option. Hatch it here. This is the true shape of the cut section. Okay. Now at the bottom you write dimensions or in mm. This is the final output for this question number 1. Okay. So while highlighting the lines, you can highlight it in a better way. Okay, here I didn't highlight it properly. So you can take the yellow color for longer edge, and you can take the red color for the shorter edge. And you can mark the longer edge, and then you can mark the shorter edge. Okay, so that it will not be confusing. Now I'll convert this into a PDF. Okay. So select center the plot, check the preview. Okay, the preview is fine. Okay. You can click OK. Exercise. It's exercise 6, I think. Okay. Section of solids. So I will share my PDF, share this PDF in my personal website. Okay, I will share the link to my website in the description box. If you want, you can go and download it. Thanks, guys. For second question, I will put it in a separate video how to draw the projection for this one. Okay. Thanks, guys.